Assalamualaikum. Okay, today me and my friend will present about assignment 1, which is camera calibration. My name is Muhammad Afiq Mustappa Kamal, and my other two friends is Nashrul Syahmi and Zainani. Okay, for this page, we can see that this is the task that has been given by our lecturer. So what we need to do is, we need to take a picture from Android, maybe around 10 or more, and then we use software such as Python Anaconda or MATLAB to run the camera calibration. What is camera calibration? The purpose of the camera calibration is to determine the geometry of the parameters of the image information process. It refers to both intrinsic or extrinsic. The intrinsic calibration focuses on the optical properties such as camera lens, focal point, visible point, and distortion coefficients. The extrinsic parameters, however, represent the location of the camera in the 3D scene. This is widely used in robotics, navigation system, and 3D scene reconstruction. The camera matrix does not allow for a distortion for the lens, since an ideal film camera does not have a lens. To accurately reflect a real camera, the camera model requires the distortion of the radial and tangential lens. Next, there are two types of distortion. First is radial distortion, which occurs when the light ray bends closer to the edge of the lens than at the optical core of the lens. The smaller the lens, the greater the distortion. As for the tangential distortion, it occurs when the lens and the image plane are not in parallel. Tangential distortion coefficient are the model of this type of distortion. Okay, next we move for the first step is by typing this type of command in MATLAB, which is Khalid GUI, and then will pop up just like in the command window. Next, all of the calibration image will be pop up. There will be only 10 because we only set 10 image. Okay, moving to the next point.
Hi, my name is Muhammad Nashrul bin Saifullah. What I want to do now, I would like to continue our presentation. So next, we will click extract grid corners. This one, the third from the top, extract grid corners to determine the corners. And then just click extract grid corners from the camera calibration toolbox. After that, this thing will appear. So what we need to do, just click enter to set as default, and just click enter again until it say do you want to use the automatic square counting mechanism. So just click enter, just press the enter to set as default to extract all grid corners for all images. And then after that, the first image will pop out. When the first image will pop out, what we need to do, just place 4 location for each corner, right? Just place the 4 location, and then after place 4 location, when you see at the right side, this is the result. The red crosser should be close to the image corner. So this is the result for the first image. Then you just press enter, and then the second image will pop up. What we need to do, we just make the same thing like before. Just place 4 location to all images, each of them, until image 10. Alright, just place 4 location, each of them, until image 10. And then look at the right side. This is the result for the image that have been placed for location. Right? That's what I need to do. want to click calibration to see the calibration result. So it will appear like this. So this is the calibration parameters. At the top, calibration parameters after initialization, and then down there, calibration result after optimization. So what is shown for the focal length, principal point, skew, and distortion, and then calibration result after optimization. There is the focal length, principal point, skew, distortion, and also have the pixel error. So let's see that the distortion for the calibration parameter after initialization is 0.0 all, but calibration result after optimization, we see that distortion have some value there. There is 0.26373, and then negative 0.84000, and then negative 0.0082, 0.01444, and 0.000. Alright, let's see what we need to do next. We just need to click show extrinsic. So we know that camera parameter are the parameter used in the camera model to describe the mathematical relationship between 3D coordinates of its projection into image plane. So after we click the show extrinsic, so we will show the extrinsic parameter for the camera center, and then if you want to switch to the camera to world center view, so just click down here. Just click here, and then it will appear like this. Alright, so efficiency parameter, also known as external parameters or camera pose, the parameters used to describe the transformation between the camera and its external world. So let's see here, this is the camera or light, and then this is the images that have been captured. So this is how the parameter that show how the images have been captured. Alright. Alright, that's all from me. Thank you.
Hi, my name is Nurul Zainani binti Zaini, metric number AE17007. Now I will continue the presentation. Okay. The next step is click analyze error. At here. Click analyze error. Then, once the projection error pop out, just move the cursor and click to show the error. The selected will show the info of the error. It's an error like that. Just click in the projection error. Next, click undistort image to see the undistort image that we want. Then just click enter to undistort all the image. All the undistort image will automatically save in the same folder of the initial image, like this. All the 1 to 10 image will automatically save in the same folder of the initial image. This is the picture of the first and second undistort image that we get. And third and fourth undistort image. Fifth and sixth undistort image. Seven and eight undistort image. 9 and 10 undistort image. Okay, this is the link of our video. This is our reference while doing this assignment. That's all from us. Thank you.